today if I can. All right, so we've just found the first order derivative, or the first derivative. Now we need to find the second derivative, or the mixed derivative. Do what? The mixed derivative. All right, some people find the mixed derivative, some people find the second derivative. What is it, 2xy erased 2xy. Okay, I find the second derivative because I think it's easier to find the second derivative. All right, you do what you want to, but the second derivative is written as f of xx and f of what? y. Now I'm going to write the academia way to write it, but I don't like it, so I'm not going to leave it up here. But you write it down in your notes. Partial derivative of f over partial derivative squared, or you can write x squared, or you can write d squared of x, whichever way you want. Okay? And the academia way, partial derivative of f over partial derivative of y squared. Okay, that's the way. So write them down in your notes. Highlight them as the academic way of writing the second derivative, or the derivative of the second order. Okay, that sounds like
Illuminati.
Sounds like, will they wear them stupid hats? The Shriners Convention or something, second order or something. Dang old KKK. Dang old, we're all racist, so it doesn't matter. All right, so I'm going, you're patriotic, you're racist. All right, so there you go. Now, take the second derivative of 2xy. Go ahead and do that. So that means you're going to treat y as a what?
As a number.
As a constant. So treat it as a constant. You're taking the second derivative of 2xy in relation to x. So that means you're going to treat y as a what? A constant. So I'm going to write 2x, and I'm going to go up here, I'm going to put 2x times 4. That's what we're doing, right? 2x times a constant.
Yeah.
So what's the derivative of 2x times 4? Well, that would be 2 times 4 times x to the 1 minus 1. That 1 comes out, that'd be 1 times 2 times 4, which would be 2 times 4 times x to the 0, which is 2 times 4, which is what?
2 times y.
2 times 4. Okay, now I take, and just like you said, I take the 4 out, and I put what?
The y in.
There you go. Simple as that. Now, eventually, it's kind of like, you know, the first time your chain comes off your bicycle, and it takes you like half a day to get it back on, and by the time the chain falls off the 5th or 6th time, you know exactly how to get it on. Same thing here. You're putting the chain on for the first time doing this example right here. But eventually, what's going to happen? You're going to start doing it in your head. Okay? And that's when you can put the chain on in just like 2 or 3 seconds. Why is the chain coming off your bicycle anyway? Nobody knows why the chain is coming off your bicycle? It's loose.
Is it too loose?
The chain is either stretched, which is very not common on a bicycle because you're not turning that many RPMs, or your axle of your rear tire has shifted which way? Forward. So you need to shift it backwards. Loosen it up, shift it backwards, and tighten up the chain. I guarantee you there's people in here that didn't know that. But that's all right. You don't need to raise your hand and say that. Oh, that's impressive. All right. So f of x is equal to what? What did I say it was? 2 what? 2y, right? All right.
I have a quick question.
F of y. Yes.
If we're treating y as a constant, I thought when you have a constant when you're doing a derivative, it's just a 0, so you wouldn't write it in.
You would if you did the product rule, 2x times y, you would if you did that. But you'd end up with 2y even if you did the product rule.
Okay.
Like I said, here we go. 2x times 4.
Yeah, that's the product part. Yeah, I got you.
Do the product rule, or you can do the power rule. Either way, you're going to get the same answer. All right, now I'm going to take x squared, unless you don't have a, yeah, we have a y function. It's y to the what? Y to the 0. Okay. X squared and y, I'm going to put y to the 0. And y to the 0, we could say is 5x to the 0, or 5y to the 0. Okay? That's a constant. We're going to treat x as a constant. All right? Okay? But what is the derivative of y to the 0? Or what is the derivative of 5?
0.
What's the derivative of 5? 0. So what's going to happen to that term? It's going to get canceled out. 0 times anything is what?
0.
0. Pull this out. 0 y to the negative 1. What's 0 times y to the negative 1? 0. What's 0 times x squared? There's no way you're not going to get a 0 here. Remember me telling you to go back to the basics if you ever get confused? Go back to the basics. Write y to the what power? 0 power. Now take that derivative. Take the derivative of y. I don't care about x. Take the derivative of y. You get 0y to the negative 1. With 0 times x, it'll knock that out. 0 times y will knock that out. You're going to get what? 0.
0.
Partial derivatives are not difficult. Why cannot people do them? Why cannot people do them? Why can people not do them? Because they are presented so fast, just like I did. I assume that you grab onto it, that you forget the basics. You forget the basics. Go back to the basics. All right, now I'm going to throw a whammy. I'm going to throw you a whammy. You ready? Now we're going to do the mixed order. F of xy, f of yx. Now, the way that you write this in academia is totally screwed up. The partial derivative of f over the partial derivative of y, partial derivative of x. You write it backwards. And this would be the partial derivative of f over the partial derivative of x, partial derivative of y. Now I'm going to erase those, but you need to write them down. And yes, they're always backwards. On xy, it's going to be partial derivative of y, partial derivative of x. On yx, it's going to be partial derivative of x, partial derivative of y. Okay, now, I'm going to erase these. And I want you to take what you've learned in the last 20, 15 minutes, and I want you to give me the derivative of the x function, of the x derivative, the first derivative, that's the first order. Oops, sorry. X, put first derivative. I want you to give me the second derivative of x in respect to what? Y. So you're going to, here's the first derivative right here. You're going to take this guy, and I want you to give me the derivative in respect to what? The second derivative in respect to x, but I want the second derivative in respect to what?
Y.
Y. In respect to y. So this right here, I'm going to highlight these two, or these four. Those and these are your second order derivatives. You're taking the second derivative of the first derivative right here. This is your first derivative, and this is your first derivative in respect to y. These are your first order derivatives. First derivative, or first order derivative. First derivative. This is technically your second derivative. Second derivative. And this is called your second mixed derivative. Okay? I don't like to call it that, but that's what it's called. Second mixed derivative. Both of these guys refer to what?
The first.
Mm-hmm. So, with what you know, with what I've taught you this morning, give me the second derivative of the x in respect to y, and give me the second derivative of y in respect to x, with respect to x. And you're going to notice something when you do that. What have you noticed? What have you noticed about the two mixed derivatives? Have you done them yet? Okay, well, I'll wait till y'all do them. I'm not going to tell you. I'm going to wait till you do them.
I don't get downstairs because.
Okay, if I'm taking the derivative of the first derivative, then y is equal to what? A constant, Hubert. That's right. So that's 2x times 4. So that'd be 2 times 4 times x. Okay, I'm taking the derivative of 2 times 4 times x. And what's the derivative of that? That'd be 8x. Or 2 times 4 times x. So, what do you get?
2xy. Yeah, it's 2xy, right?
But I don't care what you get. What have you found out? What do you find out about these two guys right here? You should get 2x. And what is the derivative of both of them? And I'm going to put this in red. The derivative here is 2x, and the derivative here is 2x. And what do you notice about these two? They're what? They're equal.
Same.
Write a note. They will always be equal. Okay? They will always be equal. And if you want to do the product rule, do the product rule. 2 times x, 2x times y. First times the derivative of the second. The derivative of the second is 1. 2 times x times 1 is what? Plus the second times the derivative of the first. One of them zeroes out, comes out to be 2x. Okay, 1 times 2x. The other one zeroes out or does something, I can't remember. You just have to do it. Do the product rule and you'll come out with 2x. But the one thing that you're going to find out is these two will be the same. Okay? Now, again, first derivative is called the first order derivative. You might want to put that down. First order derivative. This whole conglomeration right here is called the second order derivative. So make sure you can find those those first order derivatives and second order partial derivatives. Okay? Now, in second and third semester calculus and engineering, you're told to find the derivatives and you're told to find the antiderivatives and plug them into formulas. That's what you're going to do in the last part of chapter 8. You're going to take these guys right here. You're going to take these guys and you're going to plug them into a formula. Okay? And you might as well get used to that because that's probably what you're going to be doing in that statistics course that y'all said y'all were going to be taking next. Okay? That's why they want you to have this second semester calculus under your belt. All right, try this one. And I just want you to just give me the first and second derivatives. Oh, well, we'll just go through all three because the third one's going to be the same. So, how about f of xy is equal to e to the xy? I want you to find all six, which the last two, f of xy and f of yx, is going to be equal, so it's really you're finding 5. Now, I'm going to go out here. Well, I'm going to wait till y'all do it. Remember, change it e to the x to the 4, times 4, and e to the 4 times y. And that way you'll remember the chain rule. That's why that first unit was so important, that you understood how to take the derivative using the chain rule. And I'm just going to go over here, and I'm just going to go back to a review. E to the 4x, and we're just going to, and I'm going to do e to the negative 3x, and I'm going to go e to the negative 1x. We're going to do a quick review of the chain rule. And just to make things simple, the chain rule always depends on what's what?
In the parentheses.
What's inside. Always remember that. Chain rule, what's inside. And we know that the derivative of e to any x is e to any x. So what's the problem, Hubert? Well, this is what y'all do. Okay, the derivative would be e to the 4x. And that is partially correct. But what you forgot to do was the derivative of what?
Inside.
What's inside, which is, what's the derivative of 4x? 4, so the derivative of e to the 4x is 4e to the 4x. Now the reason this doesn't show up when you first take the derivative of e to the x is what's in front of this 1. And what's the derivative of 1x? 1, Hubert. And that's the multiplicative identity, which really doesn't matter. So you get, technically you say, okay, that's e to the x. But technically it's 1 times e to the 1x is what it is. Because you took the derivative of what? What's inside. A lot of people don't make that connection, especially with e to the x. So what would this be? And what would this be? And of course, you don't have to have one there. I was just trying to show you something. So, when you're taking the derivative over here, and you're doing f of little x, then that means you're going to change that y, e to the x, you're going to change that y to a 4. Okay? And then you're going to say, okay, well, the derivative of e to the x is e to the x, so that's going to give me e to the 4x. But what's the derivative of 4x?
4.
So now we take our handy dandy virtual eraser and we erase it and put a what?
Y.
A Y. So the answer is YE to the XY. And that's what y'all should have got. All right, now y'all do F of Y. And if you can't do it, just write it down as a disappointment because I've already shown you how to do it. And you probably should just not enroll in that statistic. Hey, just drop out. Self-improvement is so overrated. Just live in a ditch. Besides, we're going to get free health care and free college for everybody. Why should we not have free college for everybody? Ain't y'all ever gone to school with somebody that mom and daddy pays for everything and they don't take it seriously? That's what happens. You know when I started taking my education seriously?
So you got the bill?
Yes. When I had to start taking out student loans. That's when I started studying a little bit more. That's why I tell my children to earn their way, or you're gonna have to get student loans. I'm not paying for your education. I'll give them gas money and I'll give them money to live off of, but not paying for it because they won't take it seriously. But I'm a racist. So. And a misogynist, and what's the other one called? Fascist. Fascist, and what else? There's one more. It's got an X in front of it.
Xenophobia.
Xenophobia.
Oh, yeah.
I don't even know what the hell that means. I think that means I don't like foreigners.
I thought it was Jews.
Or is that a misogynist? No, misogynist.
You don't like females.
All straight.
I think they're from Australia.
Is that somebody that likes massages? Is that what it is? Okay, nobody's going to talk to me. Y'all have no idea what I'm talking about. But anyway. F of little y. So that means I want to take the derivative of e to the xy, but this time I'm going to change x to the what? To the 4. So e to the 4y. And that's going to come out to be e to the 4y.
Priority 1 message coming in.
And what's the derivative of 4y?
4.
4. So 4e to the 4y. And I take my handy dandy technical eraser here. And I take that out, and I take that out, and replace it with what?
X.
There you go. And y'all all should have got that. Now, do you see a pattern there? If you're taking the derivative of e to the xy in relation to y, what's going to be in front of it?
X.
And there's a pattern there. I'm going to let y'all come up with the pattern because it's real difficult. All right, now while y'all are finding the second derivative, I'm going to go and erase all this stuff so I can have some more space. So I'm going to erase all this. And erase all this. I know this ain't going to work, but I'll try it anyway. Oh my gosh, it did work. Nope, I knew it wouldn't work. Yep, I knew it wouldn't work. Damn Russians. It's a conspiracy. X, e to the xy. I'll erase all this other stuff. Okay, I saw Heredity.
What do you think?
Pretty stupid.
The ending was weird.
Yeah, it was really. I'm glad they didn't have no high-priced actors in it, or actresses, or whatever, because it was really a stupid movie. I'm glad I got it on Fire Stick, so I didn't pay for it.
Wasn't even that scary.
What'd you say?
Wasn't even that scary.
No, it wasn't.
The best part was like the graphic detail they had. That's what made it kind of shock factor.
Yeah, it was. It was on a scale from 1, as far as scary, I'd say it's probably a 4 or 5. It wasn't nothing like Mama or Annabelle or Conjuring.
Are you gonna watch The Nun when it comes out?
Oh, hey, I got it down on my dadgum calendar. And Megalodon, I got that on my calendar too.
Oh yeah.
Since we're not going to get Jaws recreated, might as well go with Megalodon. Because Shallows was depressing. So I didn't. The Shallows. I mean, if they would take the Shallow, the shark on Shallow, and take that shark and put it on Jaws, man, we'd have a great Jaws. But they don't. Nobody. Steven Spielberg says he don't want to do it. Says he doesn't remake his own movies. That's what he says. Well, maybe he'll tell somebody else to do it.
Yeah.
That and Christine. I think Christine needs to be done with computer graphics. And then there's going to be Halloween, and then Halloween, The Nun, and The Meg. Those are the 3 movies that I'm kind of wanting to see. All right, y'all finished with F of double X and F of double Y?
Yes.
Actually, when you do these, you can just think in relation, well, I'll just take the derivative, and the only thing that changes, because the derivative of e to the xy is e to the xy, but what's out in front? Y, so another y is going to be out front. So what will f of xx be?
Is it xy?
Y what? Y squared e to the xy. And what do y'all think f of yy is going to be? X squared e to the xy. See, after you start doing some of these things, you're going to start seeing patterns. And that's what mathematics is, seeing patterns. All right? So, f of yy sounds like a song, would be x squared e to the xy. Now, since you have, this is not a constant anymore, it's a square, it's something to a, you're going to have to use the what? The power rule. Now, I did it for f of xy. Let's see if I can, I'm going to do it right here. I think I did f of xy. Yeah, f of xy. I'm going to let y'all do f of xy with the power rule and see what you come out with. Now remember, you're doing the power rule in respect to what?
Y squared.
Y. In respect to y. And you're not taking the derivative here. Well, yeah, you are. Yeah, just go ahead and do the derivative. Because you're not taking the second derivative of the second derivative. You're taking the second derivative of the what? First derivative. Remember, these two, you're taking the derivative of this guy. So this is going to be first times the derivative of the second, and I'm going to write the derivative in, I'm going to write it derivative of y first times the derivative of the second plus the second times the derivative of the what? think about this. If you're taking the derivative of e to the xy in relation to y, then what are you looking at? You're looking at the f of y, Hubert. That's right. So I can just rewrite this as y. I'm sorry. I can rewrite this as y times what? What's the derivative of e to the xy in relation to y?
X e to the xy.
Thank you. I don't want y'all to have to work extra. Plus, I'll do this one. The derivative of y is 1. There we go. I'll put a 1 here for you. And now what can you factor out? Well, you don't have to factor out. I'm just going to write xy e to the xy plus e to the xy, and then I'm going to put or, and you need to highlight or because that's a big or. A lot of people, once you do the second derivative or the mixed derivative, the teacher don't really care whether you simplify it or not. So that's going to be e to the xy, and that's going to be what? Xy plus 1. And if you do f of yx, you'll come out with the same thing. That's a good one to know because you as economics majors, marketing majors, business majors, what am I going to ask you to do? Am I going to ask you to do derivative of x squared y, or am I going to ask you to do e to the x? I'm going to ask you to do e to the x, or 2 to the x power. Remember, your two functions that you worry about all the time is f of x is equal to e to the x, and f of x is equal to some number to the what power? To the x power. Those are your two functions that you need to know all about because they're always in the first quadrant and they're always pertaining to an increase or what?
Decrease.
Decreased. Okay? And that's why this one is probably a good test question, or anything having to do with E is going to be a good test question. Okay? Comprende?
Yep.
Feeling a little bit better about partial derivatives now?
A bit.
A little bit? All right, well, I'm going to go back to what we did the other day. Now let's revisit the two that we did in class. For those that wasn't here, you're getting whatever class we had last, you're getting it in. Wednesday. F of x, y. Except this time, I don't want you to just do the partial derivative. I want you to do the second derivative also. So f of x, y is equal to 3x minus 2y to the fourth. All right? Take a few minutes, and I want you to find the first order derivative and the second order derivative. Now this is a simple one, so it probably is going to zero itself out. So what's f of x?
3.
I heard 3. I guess that was 3. F of x is equal to 3, the derivative in respect of 3. This is 0 because it's a constant. The whole term is a constant. So that'd be 3 minus 0, which is 3. F of y is going to be equal to negative 8y cubed. So if you wanted to do f of double x, well, that's pretty simple. What would f of double x be?
0.
I heard somebody whisper 0. Is that it? You reckon that's the answer?
Yeah.
Okay. We'll whisper the rest of the class. We'll whisper.
The Russians can't hear us this way.
Then you just, I don't know. Doesn't matter if I can hear y'all, so it don't matter.
Priority 1 message coming in on secure channel.
Oh, I'm sorry. I was thinking of the next. I'm sorry. Thank you, Miss Kubu, as always, for finding my errors. F of YY. Ya. That's what I'm thinking of. Sandra Bullock movie. The Ya Sisterhood. Sisterhood of the Ya Club or whatever. Huh? No. Ya Club. She's in a movie. It's kind of like Steel Magnolias, only it's the Ya Club. Ya Sisterhood. Yeah.
It's around the
I'm a
same.
Sandra Bullock nut, so anyway. All right, so this is pretty simple. What would it be? Negative what? Negative 24y squared. And see, I only asked for the second derivative there because if I asked you for the xy, you're going to zero it out. So that's why I'm not asking for that one. All right, let's try the one that we did the other day in relation to 3. F of x, y, z. And I'm going to let y'all do this one. Equals x, y to the second, z to the third, plus 3y, z. Just find the first derivative. Find the f of x, f of y, and f of z. So f of x is going to be equal to, well, this would be the same, these two would be the same as 4x, right? Treat that as a 4 and that as an x. So what's the derivative of 4x?
4.
4, so 4 is equal to y squared z cubed plus, well, this doesn't have an x in it, so you're not taking the derivative of it. If you're not taking the derivative of it, it just what? What does it do if you don't take the derivative of it? It just comes down. Okay, now you need to make that note. All right? A lot of you will say, well, I don't understand that. It needs to be 0. Did you take the derivative of anything? No, you didn't. So if you don't take the derivative of something, what does it do? It just comes down. So this just comes down because there's no derivative here. There's no x here. I can't, no x to take derivative of. So you can't just say, okay, well, there's no x, so I'm just going to take the derivative of whatever's there. You can't do that. That's making up your own rules as you go along. Well, I don't know. We got some females in the group. That's their deal. Okay? But some of y'all just didn't even hear it. You didn't even say a word. That's all right. If you don't pay attention, that's fine. F of y. What's the woman's prerogative?
Change your mind.
Change their mind, exactly. And guys, it don't matter if it's in midstream. Change your mind. Yes, you go right ahead, change your mind. I'll do whatever you want me to do. That's the proper answer.
For f of x.
No, I'm not on f of x now. I'm doing f of y. What?
Last class, I wrote down plus 0, like we did plus 3 y as a constant.
I should have. Well, the reason is change it because I should have wrote down no x. Therefore, it's 3y. Yeah, I meant it drops down. Yes, I shouldn't have wrote 0 there. I'm sorry. Drops down. All right, now f of y. F of y, you're going to get 2y xz cubed plus 3z. Because that y turns into a 1. Okay? So here, what is the derivative? What is the derivative? I'm sorry, I'm taking the derivative right here. What is the derivative of y squared?
Put it down because there's not an x in it.
2x.
Or 2y, right? So that'd be 2y times x z to the third, because it just comes down, plus, what's the derivative of y? 1 times 3z. I'm just going to write it like that because you can simplify it. Y'all are good algebra students. I'm not going to worry with that. And now do f of z.
Hubert,
Yes.
do you have to combine like the x and the z cubed together?
What's 2 times 3?
6.
What's 3 times 2?
6.
Do you?
No. I just left the x where it was and
Yeah,
then
that's
did the
fine. Always
Okay.
remember, multiplication is commutative. It don't matter where you do x, y, z, or z, y, x, or y, z, whatever. Doesn't matter, because 2 times 3, same as 3 times 2. These are what? This is all what? Multiplication. So it doesn't matter what order you put them in.
Okay.
Okay? All right, what's the derivative of z to the third?
3z squared.
3z squared. And some of y'all are starting to see, take the derivative and then what? Just bring the rest what? Down. Hopefully you're starting to see that. Okay, let's go here. What's the derivative of z? 1. And then 3y comes down. That's a test question because that's in the third dimension. I want you to be able to do that. That's a test question. So far I've given you 2 test questions as far as partial derivatives. One being e to the x, the other being 3 dimensions. Okay?
I have a question.
Now I'm not going to ask you to do the second derivative, okay? Because the second derivative, hold on just a second. If you did the second derivative, well, see the x went away in the first derivative, so the second derivative is just going to be the same thing. So that's really no point in doing that one. F of y, the y is going to turn into 1, so that's going to just leave you with 2xz cubed. The 3z is going to stay the same because there's no y term there. So this problem is not designed to do a second derivative. Okay? What's your question?
Okay, so on the last one we did, it was like 3x minus 2y. Why would you not just bring that 2y down then, since there's to take the derivative up?
What now?
So like on that one, why would you not just bring the 2y down, since there's to take the derivative of x on that, like we're doing on the other one? see what I'm saying?
I'm thinking, let's see. Okay, that's incorrect. You're right. That's incorrect. This should be minus 2y. Go back to this one.
So then technically shouldn't the f of y also have the 3x? Because there's nothing, you can't take the derivative of y with the 3x. So there's not a lot to take the derivative of.
Let me go back to that one. Let me go back to that one and I'll figure that one out because I've got it down as, hold on a second. Let me see. I think it has to do basically with the product rule. See, in the second one, you've got 3 things multiplied, and in the first one, you've got 2 multiplied. And I think it has a lot to do, because what's the derivative of 2? 0. And I think it zeroes out that term, and that's why. I'll have to look to make sure. But in the second one, y times z, you're not going to get rid of y times z because of what? The derivative of the 3 will turn to 0, but the y and the z will turn to 1s. And I think it has to do with how many terms you have, but I'll verify that before. Verify that Thursday. Remind me Thursday. Okay? I'll look at it between now and Thursday and find that out. But I believe it has a lot to do with how many terms you've got here. And because first times the derivative of the second, 4y to the third, plus the second times the derivative of the first, which is 0, that goes out. And I think that's one of the reasons this one goes out to 0 where the other one doesn't. Because the other one has x, y, the derivative of the first is 1 times the derivative of the second, 1x times the derivative of 1. And see, these do not go out, all right, where this one does. And I think that has something to do with it, but I'll verify. It has to do with the number of terms. I'll check on it. Now, what I want to do now is I want to shift over to chapter 8. Or not chapter 8. The first part, the third part of where we're going with all this. Okay, the first part is being able to do graphs. Second part, being able to do partial derivatives. Thursday, we're going to keep doing partial derivatives, and we're going to keep doing this. So that's it. That's all we're going to do. Partial derivatives, graphs, and these. So f of x is equal to xy times 1 minus x minus y. Now, you're going to have to find everything on this, but the first thing I would suggest you do, what would I suggest you do on this one before you even get started? Distribute. Write it down and highlight it. Why? Because if you don't distribute, you're going to have to use the product rule. X times y with the 1 minus, and that's going to be a cluster. So the best thing to do is to distribute the x. So you need to write that down. Rewrite it as f of x is equal to xy minus x squared y minus xy squared. And see, you've got the sum of 3 terms, and you can take the derivative of the sum of 3 terms easier than you can factored form. You see what I'm saying? So you need to highlight that. Highlight that and put out to the side. Rewrite, distribute, make it easier. All right, now you can find the first derivative in respect to x and the first derivative in respect to y. we'll just go to the first and second derivatives on these, and then Thursday we'll put in the second derivative test, which is plugging it into a formula. All right, so the derivative of x, we're going to take the respectful x terms and take the derivative of the x and leave the y as a constant, right? So what will the first one be? That'd be 1 times y minus y times what? 2x. Minus, and I'll tell you what, let's do the derivative here. That's 2x. We'll do that in red, and this one right here, 1. And what's the derivative of x? 1 times y squared. And that's going to be equal to y minus 2xy minus y squared. All right, now you do f of y. So, what's the derivative of y? 1. So that's going to be a 1 right there. And then a 1 right there. And then a 2y right there. And then, of course, x right there minus x squared. And minus x right there. And that's going to be x minus x squared minus 2xy. What do you notice about them? Well, if you interchange these two right here, what would you get?
About the same thing, but with x.
Exactly. See it?
Mm-hmm.
And you'll start to see these patterns. You'll start to see them as you do problems. Okay, now I want you to find double x and double y. And we'll do another problem and find first and second order. And then we'll do more of the mixed terms Thursday. Okay, on this one, I want you to do I want you to put something in here like this. Do that, and I think that will answer your question. You've got to remember, if you're in terms, you've got to remember the basics. There is a 1 there. And if there is a 1 in front of that y, how do you write it in terms of x? You write it in terms of x to the 0 power. And what that's going to do is going to zero some stuff out. That answers your question. So I think that problem that I said to bring it down, it probably will zero out. I'm not sure. I have to look at it. It can be confusing. These can be. That's why you have to be careful. So f of xx, I'm going to write it out. If I take the derivative of x to the 0 power, what will that do to that whole term? Zero it out. So the first term goes to 0. All right? And then take the derivative of 2xy. What is the derivative of 2x? And then the y comes down, 2y. And then the 0 term cancels out there. So as far as f of x, fxx is equal to negative 2y. All right, now you do f of yy. And then what would f of yy be? Well, that would be, I'm just going to rewrite it. I'm not going to go through and do the zeros, but the first term right here will go out. Second term will go out, and that'll leave negative 2 what? Opposite of this would be negative 2 what?
X.
There you go. And again, you see this pattern that you see with each level. Right quick, just in our heads, f of xy. What's y? What's the derivative of y? 1. What's the derivative of y? 1 times 2x is 2x. And what's the derivative of y here?
2y.
2y. So that would be minus 2y times 1. And you should get the same thing down here. Let's see. F of yx. All right. What's the derivative of x? 1. What's the derivative of negative 2x? And what's the derivative of x squared? Do we get the same thing?
Yep.
Now, is that thunder? It's supposed to rain today. Hope it does. Oh, that was you kicking the door back there. All right. Question on that. That's what it's supposed to, that's what's supposed to happen. You're supposed to get the first derivative, the second derivative, and when you take x, y, and yx, they should do what?
Be the same.
They should be the same. I think I got one more I want you to do, and then Thursday we're going to do the second part of these, which entails f of xy and f of yx. Oh, that took me 3 pages. Do this one. And you might want to keep these pages separate or keep them to where you have a page after, because we're going to continue the second part of this one. So leave a half a page to a page after this one, and then go to another clean page and write example 2 down. And this will be f of xy is equal to x to the third minus 12xy plus 8y cubed. All right, go ahead and find f of x, f of y, f of xx, and f of yy. Y. Yeah. If I put any homework up tonight, it'll be, I'll probably call it Chapter 8, and I'll probably call it Partial Derivatives Mixed or something like that, because I may put some in there that has the x, y on it.
Did you take the derivative? No, because there's no x, so you can't. So you just pull it down. At least that's what I did. Yeah.
Okay, so here, f of x what's the derivative of x cubed?
3x squared.
Squared. What's the derivative of x?
1.
1, so I'm going to put a 1 here, and I'm going to bring down 12y. And then 8y cubed should be zeroed out, because what do you have in front of it? X to the what? X to the 0, and that zeroes out, so that will be 0. You got to remember.
So why in the other one pull it down?
You got to remember to. That's why I said a while ago that term should be 0, because I must have messed up. Each term you have to have an x term in it. X to the third, x to the first, x to the 0. Each term has to have an x term in it. If it's not one there, you have to add it. And I added x to the 0 because there wasn't one there. Remember me telling you, go back to the basics? If you go back to the basics, then you'll see the 0 here goes out front. That comes to -1, but it zeroes out the whole term. That's why it goes to 0. If you'll follow that x to the 0, it won't lead you astray. F of y, you put in y to the 0 if there's any y missing. So here you would put in a y to the 0. So I'll put in a y to the 0 there. Any other y's missing? Nope. So what happened to that first term? First term goes to 0. What is the y? What is the derivative of y to the first power? 1. You see the pattern?
Yep.
Plus, and in this case, you're going to get a derivative. You got a derivative on the first one, and not on the last one with this one. This one, you're going to get a derivative with the last one, but not the first one. It's always, and what you're thinking about, do y'all remember back in algebra when you wanted to find the perpendicular? What did the slopes do? If your slope on the first line was 1/2, what's the slope on the second line? And it's always the inverse, it's always the opposite what? It's always the opposite reciprocal. Do y'all remember that? All right?
Yeah.
Think about what you're finding here. You're in a 3-dimensional or 2-dimensional graph or 3-dimensional graph, and you're trying to find points in space. So that's why you're seeing a lot of this reciprocation, and you're seeing a lot of these patterns because of you dealing with the X and the Y. You're seeing a lot of the flip-flop. Okay, I'm not saying it's the perpendicular. I'm just telling you that that's why you're seeing a lot of these relationships. Okay, so what is the derivative of, what am I taking the derivative of? Let's see.
Y cubed.
Y. So what's Y? What is that? 24 what? Y squared? Should be 24Y squared. 24Y
Priority 1 message coming in on
Now
the
take
channel.
and find double X and find double Y.
So every time that changes, it's like three variables or terms.
What do you mean 3 different terms?
Wow, we dropped it down with the X, Y.
Well, what you're going to have to do is go back to that 3 while we're on this one right now. But when you go back to that one, if you have a missing X or a missing Y, put in an X to the 0 or Y to the 0 when you're taking that derivative.
It should change.
It should change it. That term I think should be 0.
Yeah.
Okay, I think Ms. Kubu was correct. I think I wrote it down wrong. Okay. All right, so here, taking the derivative of X, well, basically we got out here 3x squared minus 12y. Now we're taking the derivative with x, so that means there's an x to the 0 power out here. Okay? Crank it out. What do you get? How much?
6x.
6x, exactly. 6x. Is it negative or positive? 6x positive. 6x what? 6x? Okay. And y. So you're going to put a y to the 0. So that will cancel out, and you're left with 48 what? 48y. Now I want you to, just for giggles, here's your x and your y. What is your y? Your negative 12. Somebody check me. Negative 12x plus 24y squared. Is that what you got? Take the derivative x in relation to y. So that would be a y to the 0 right here. And there would be an x to the 0 here. And see what happens. See if they come out to be the same. It should be negative 12. Does it come out to be negative 12? That's what I got. It should come out to be negative 12. Yeah. So this goes out. So what's left? X, Y. What would X, Y be? Negative what?
12.
Negative 12. So f of x, y, negative 12. What would yx be? Well, take out this one. What's left? What's the derivative of negative 12x? Negative 12. And again, we see that the two mixed terms come out to be equal. Yes, sir.
I'm sorry, I missed for the fxx. How'd you get 6?
Okay, right over here. Okay, when you're finding the x term, that means if there's an x term anywhere, you're going to put a 0 there. Okay?
Right.
Okay, if there's a missing term, all right, so just get rid of that blue one because I did that with the y. So, okay, so what does this term do in relation to the x derivative? What happens? It goes out, and that leaves what? The derivative of y, or is that an x? That's an x.
Yeah.
What's the derivative of 3x squared? All right, the y. You got you're taking the derivative of the y right here, so you got to put a y to the 0 wherever there was one right here, and that goes out. What does that leave here? 3hy. So you see, you got to take some time, and you have to work with these things, and eventually you'll see the light come on, and you'll see how to actually do them. All right, but you're not going to get them. It's kind of like, you're going to go on a diet and you eat a Big Mac every other day instead of every day. Are you going to lose weight? No. Okay? You're not going to go home and just go, okay, I'll look over the notes. Look over the notes. You're not going to do it that way. Okay? The only way that you're going to, even I messed up on one of them a while ago, that three-dimensional one, because I forgot to put the y to the 0 or the x to the 0 in there, and if you forget to do that, then it's going to botch up your whole problem. So you've got to learn it, okay? That's why it's called partial. It's not the easiest thing. That's why differential equations. This right here is differential equations. This is what you're doing. You're differentiating equations in terms of time. In different Q is in terms of time. All right? And that's what you're doing. And not all of us walk around, and I sure don't, walk around doing differential equations in our head all the time. So it's not like, if you did this in your head, then you'd be pretty much weird. Okay? Because you don't do it. So it's kind of like the rusty bicycle chain. It doesn't get better until you oil it and you actually start using it, and then you can work through it. Now, Thursday, we're going to do the same thing. We're going to continue with this and do some more partial fractions. I will put some more homework up with partial fractions, doing the x and the y. So probably 5 or 6 problems, and y'all look for them, okay? All right, see y'all later. Have a good day. See y'all later.